All right, welcome back, Hononegah, Algebra 1. You just got done taking a 9.1 to 9.5 assessment, and hopefully you guys, everybody was able to do that and stuff, and hopefully you understood most of the material and did well on it. Obviously, I want to hear how everybody was doing, and so please communicate that with your teachers. Remember, grades can only go up. If you have not taken it, we'll take everything late a little bit, so please make sure that you get that done if possible. It's in a Google form. And so some of it's multiple choice and some of it's not. So here we go, moving on to 9.6 and solving nonlinear systems. And now this is an old question. These are all lines. And we can do substitution or elimination. And I'm going to be very honest with you, and I'm probably going off script here a little bit with some of the other teachers, but I do all of these by substitution. So if y equals 3x plus 14 and y equals negative 4x, then negative 4x equals 3x plus 14, because again, they're both equal to the same thing. So they're both equal to y. So I can set them equal to each other. And so subtracting 3x, I get x to equal, using some algebra skills here, x to be negative 2. And then I'm going to go back up here, and in place of x, I'm going to put negative 2. And I can put it into either equation. That doesn't make any difference. So I can put it into the top equation or the bottom equation. That doesn't matter. So if I put negative 2 into the bottom equation for x, negative 4 times negative 2 is 8. So the answer to this question, and I always like to write them as points. Now your teacher may differ from me, but x equals negative 2, y equals 8. So that is the point, negative 2, 8. Same thing with the other one here. If y equals negative x minus 2 and y equals 3x plus 6, then I can set those equal to each other because they're both equaling the same thing. Solving, so I'm going to subtract 3x and get negative 4x. I'm going to add 2 to get 8. And so using some algebra skills, x equals negative 2. Putting that back into one of these two equations, and I'm going to do the bottom one here. 3 times negative 2 plus 6, I get y to equal 0. So if x equals negative 2 and y equals 0, then that is the point negative 2, 0. So again, these are lines, and these are two lines that cross, and they cross at the point negative 2, 0. So that's why I don't like leaving my answers separate, because I like understanding the fact that this is the x, this is the y, and therefore that is the point. So now doing the exact same thing, except now we're going to have the top one is a parabola, and the bottom one is a line. So now think about this a little bit. If I had a parabola and a line, there's one of basically three things that could happen. They could cross with 2 points. They could touch, so I have a line that just touches, or I have no solution. I have a parabola and a line that never cross. So if y equals x squared plus x minus 1 and y equals negative 2x plus 3, just like I did in the previous slide, if they both equal y, then I can set them both equal to each other. I'm going to add 2x to both sides. I'm going to subtract 3 from both sides. And now I can use one of the methods that I've learned previously. I can factor this, and this one actually does factor, which makes life a little bit easier. Factors of negative 4 that get me 3 would be 4 and negative 1. Set the parentheses equal to 0. So I've got x plus 4 equaling 0, x minus 1 equaling 0. So I get x equals negative 4 and x equals 1. Now, plug those back in. So I'm going to plug x equaling 1 back into the line. I'm going to be honest with all of you. If you have a line and a parabola, always use the line. So if I put 1 in for x, I get y to equal 1, which means when the x is 1, the y is 1. Now I'm going to put negative 4 in for x. So negative 2 times 4 plus 3. So negative 8 plus 3 is 5. So when the x is negative 4, the y is 5. So notice you get a different answer. So for the 1, when you plug it in, you get 1. When you plug negative 4 in, you get 5. So that is this scenario right here that we talked about up in the beginning. We have a scenario in which we have a parabola and a line, and they cross in two locations. If you have a graphing calculator, go ahead and go into the y equals and type this in. And go into the y equals and type this in. And then look at the fact that you have a parabola and a line, and they cross in two different locations. Now, if you were in class, we'd actually do a graphing calculator exercise, but because you're not in class, then that makes things just a little bit more complicated. But this would be a good section for a graphing calculator exercise. So if you guys have a graphing calculator, by all means use it. Or Desmos is another opportunity, desmos.com. You go to y, type in y equals x squared plus x minus 1, type in y equals negative 2x plus 3, and that would give you an opportunity to see both those points again. So continuing here, y equals, and again, I know it says elimination up here, but I'm going to do things by substitution, so I apologize to all the other Algebra 1 teachers. I'm doing it my own way here. I'm going to add 3x, so x squared. I'm going to add 8. So I get plus 6. So these two cancel each other out. Wait a minute. I can solve this using one of my other methods here. Hold on just a second. All right. So x squared equals negative 6. Take the square root of both sides. Wait a minute. I can't take the square root of a negative, so that's no solution. So again, if you were looking at this visually, you're talking about a parabola and a line that never cross, which is why this would be no solution. You can't do an intersection of something that doesn't actually cross. So I set them equal to each other, solve it for, make it equal 0, and then pick one of my methods to actually solve. That is it for today. If you have any questions, make sure this is a very short lesson. Make sure you talk to your teacher, but section 9.6. Good luck and be safe.